Ladies and gentlemen, welcome to the class 3.3 and then finally the last class of this cycle of lesson. For sure the course will be implemented in the future with some additional classes, additional lesson, because this course is very open, it's still at the very beginning in the School of Architecture of Tianjin University, but I think it's a good opportunity at least to start. Those kind of research is quite complex and it will stand for several years. The class 3.2 second part, which you can call 3.3, it is divided mainly in three parts. The first part, we will talk about the idea of cellular automata, but we will try to go deep into the topic of cellular automata inside the artificial intelligence. How can we apply, how can we combine together cellular automata and artificial intelligence? The second part of this last cycle concerned the use of genetic algorithms and artificial intelligence, and finally we will touch, at least in the general issue, the idea of neural network, which is probably one of very good and very advanced technique which will become one of the future bases for the artificial intelligence. First, we have to remind ourselves the possible application of cellular automata in the field of architecture. Yes, because until now we have illustrated some technology, some concept, some possibility in the cellular automata, but then we have some prevision or at least some element where cellular automata are already applied or it may be applied. One is the area of technology, ecology, humanities, economics, agriculture, science, art, and urban development. All those elements, even if it appear far from each other, they are definitely all related with the architecture. Technology is clear because architecture is very close to the building technology. Ecology, that is one of the most important fields of our research, and in general it is the main trend of the architecture and urban planning in the last years. Humanities, well, that is very obvious because the core of the architecture, it is always humanities, a human being, how the people behave and live. This is the logic of architecture. Economy, because definitely the topic of urban planning, which is one of our main concern, it is always related on the macro and micro scale of the human activity and how the economy intervene on those geographic and bioregion area. It's fundamental. Agriculture, also a key point, because in fact the urban planning should always concern the closed cycle in between cities and the ecological surrounding, and the provisioning of the food for the human settlement, it is a key element. Art, definitely yes, because architecture it is and it will be always a form of art. And urban development, and I won't even extend this idea in urban study, it is a fundamental point because the cellular automata is very able to describe the movement of the people inside the city, but also the urban growth. We already see some experiment in the past lesson, and we will see something even more interesting in this last class. One point that we already discussed, but I want to remark again because it's very important and fundamentally in every possible discussion about cellular automata, it is the fact that the cellular automata is a very simple system with a very simple rule, but it is able to provide elaboration of very complex systems. Now, the sentence in front of you concerns the fact that it is only focused on surveying, which it means investigation, which it means analysis, it means discovering of a certain existing situation. But in fact, cellular automata, in my opinion, in my personal opinion, is something even more. Because the cellular automata, even with many mistakes, even with many problems in the methodology of application of cellular automata inside the architecture and urban study and urban design, in all this kind of field, I don't think the cellular automata is useful only in surveying, only in analysis, because cellular automata is extremely able to generate also possible design. Somehow, cellular automata and his possible of self-developing, it is very good to understand how the natural system, include the city, because the city is a sort of growing system, how the natural system, how the cities, how the population behave, act, and generate situation into the real life. This is for surveying, but it is also true that the cellular automata, and we will see some example, the cellular automata is also able to create a sort of prevision about how the city could grow in the following decades. There are several studies, we already mentioned some of them, but there are also additional studies that we will illustrate very soon, that the cellular automata can generate a sort of prevision about how the future city may be according with a certain trend. So, cellular automata and his very simple inherent rule can describe very complex system. The sentence say complex physical and biological system. The biological system, the physical system, and attention, in this case, intentionally it is distinguished physical and biological, because the cellular automata can equally describe, it's very able to describe the non-living system, but also the biological system, which means the living system. Cellular automata is an extremely powerful way to create process of development, but also process of analysis. Cellular automata, in short, is able to understand the real complexity of the living and non-living system. I won't take back some element that we already discussed before, but very useful to refresh our mind. When we discuss about cellular automata, we always discuss about lattice, cell state, neighborhood, transition rule, and time. But now we are quite experienced about all those issues, because we already discussed many times. Lattice, it is the space where the cellular automata exist and operate. The cell state is the status of the single cell, can be activated, deactivated, and remember that every cell is in relationship with the rest. The neighborhood is exactly the rest, which it means the relationship in between the single cell and the system. Actually, the neighborhood, it is more related on the cell which is really very close on the cell which under examination. Then the transition rules are, in short, the rules that change the cellular automata process of development. In this sentence, we mentioned that they are formulated in general with the code if, then, and else. But we already know very well. The time, this is very important because the time have to be limited and discrete, and the length of the time cannot be endless. So these elements, we remind, are the fundamental issue concerning the operation of cellular automata. So the cellular automata, it is an imitating process. This one have to be very important in every consideration about cellular automata. And of course, artificial intelligence. And this is one of the reasons why this paper, it doesn't mention, but I won't add my own opinion, my own vision. This is why the coupling, the integration in between cellular automata and artificial intelligence becomes so interesting for us. It is clear, because we already discussed many times, and this paper reiterated the concept, that the cellular automata is a simple process, simple rules, which can generate complex effect, complex spatial process. But the issue is, if we integrate cellular automata and artificial intelligence, what we have is a process which is not automatic, but it is intelligent. Let me explain the issue. When we have a cellular automata, somehow the process is, yes, complex, but is still a little bit stupid. Like stupid is one bacteria or one virus, or at least it is not following the idea of human intelligence. how arrogant we are to consider the human intelligence something which is meaningful. In my personal opinion, the human intelligence, it is just one of the minor process in the development, not of the universe, but even in the development of these small planets. So it is simply inconsistent. It is not really very important. But because we are selfish, because we human beings are even blind in the conception of the universe, we arrogant consider the human intelligence something which is valuable, but actually it is not. Anyway, if the cellular automata, which is a very general principle, can be integrated with artificial intelligence, something interesting can come out. Cellular automata, it is a form of development which is automatic, not completely stupid, but not integrated, not following the intelligence of the human being. What happens if the development of the cellular automata can be integrated with the human intelligence? If there is one character of the human intelligence, it is probably intention, projection. One interesting side of the human intelligence, which I don't mean that it is really interesting, it is really objective, it is really meaningful, but one characteristic of this strange species is the ability of projection, the ability of intention. A human being wants something and create the form, modify the environment to reach that specific goal. In most of the cases it is useless, sometimes could be useful. But the cellular automata doesn't have intention. And this is very interesting. The cellular automata, like bacteria and virus, simply replicate itself in a very complex dynamic. But what happens if the rule of the modification, rule of growing, the transition rule has a sort of projection, has a sort of intention? In this case, we are really in front of artificial intelligence applied in cellular automata. That is a very interesting direction. One very interesting point of cellular automata and artificial intelligence applied, for example, in the urban planning, in the urban design, it is the prediction and simulation how the urban settlement can be developed, can grow. Attention, in this case, what I mean is development both in the case of space structure, urban configuration, sites, transportation system, and so on. But also I mean how the people use the existing space. That is a very interesting element in the cellular automata. But attention, until now, the cellular automata process is not integrated with artificial intelligence. So the challenge for the near future is to integrate those two key concepts. Read together this slide. In the urban analysis and in the urban simulation, the cellular automata could concern technique like economic principle, statistical analysis, and spatial interaction. For example, the economic principle. They are relationship between urban land use and the value of urban land. The renewed interest for geography in economics offer concepts to analyze the spatial interaction between actors in terms of centripetal forces leading to concentration and centrifugal forces leading to spatial spread of function. On this point, I must remark two research under development of two of my brilliant students. The first one, it is Ashenafi Mehari from Ethiopia, who is going to use some mathematical process to demonstrate that the multi-center city, it is more convenient than the single core city. His research, it is not strictly related on cellular automata, or better, there is no connection with the cellular automata, but I want to mention because the element of mathematics apply on the urban growth and especially on the urban structures, it is the very good direction in every possible analysis, in every future analysis of the urban structures. The second research, it is from another very nice student of my team, who is Bushra Zahir, who is studying the sustainable transportation and smart node in the Pakistan cities. So the question is, in which way a smart transportation system, smart node, sustainable transportation system could influence in a positive way the existing city? Also in this case, I think the cellular automata, but even more the artificial intelligence and probably the neural network could be the right direction for develop this research. So I give the best wishes to these two brilliant students for their study. So my point is the element of economy and statistical and space element is very important in every urban study. Cellular automata and artificial intelligence are the key. We can continue. Statistical analysis. Static models calculate the situation at a given point in time. They can be used to simulate possible spatial development within a relatively short time span under business as usual conditions. They are not suited to simulate possible changes according to diverging future scenarios. In this case, statistical system is a very powerful technique because it may not give the ultimate certain possible solution for a certain kind of urban structures, for example. But the statistical method, and this is the key element in our discussion, it is possible solution. Statistical, it is not concentrate on one ultimate, final, certain situation. There is no certain situation in the real life. The real life, it is based on a continuous change, on possible solution, on dynamic situation. There is no any ultimate and fixed solution. This is very interesting because it's very close to the Oriental philosophy, where everything is a process and there is no ultimate state in the reality. The last element that we want to discuss, it is a spatial interaction. In a social geographical context, refers to every movement in a space as a consequence of a human process. Assumption that land use is influenced by the available infrastructure network and vice versa is a key element in our discussion. The transportation depends on the spatial configuration of different, mostly urban, land use types. Remember that the space interaction, which it means the mutual relationship in between different space inside an urban context, it is a very important point in every discussion, because if we understand, if we try to think which components are essential in urban analysis, we cannot avoid to consider the space as one, I cannot say the main point, but one of the most important point in every possible analysis. So we have a space, we have a square, we have a road, we have a living area, we have a commercial area, but mostly we are in front of space. The mutual interaction in between spaces generate the dynamic of the city. These three elements, economy, statistics, and space interaction, it is a very important point in every possible discussion about city. Cellular automata and artificial intelligence, it is one of the elements which may help these three components. We have to remember that the complexity of the urban system is extremely high, and there is no mathematics which is able until now to generate a possible solution, a possible prevision. Cellular automata, artificial intelligence, and genetic algorithms can be very close, but the reality is something much more complicated than any possible analysis. The previous element that we discussed, economic, statistical, spatial, it is an element which finally is going to describe the interaction in between multiple factors. So we have to remember that it is something like in the game of Wei Qi, the Chinese game of Wei Qi. There are always a big scenario and some sub-scenario. It is like in a large-scale war where there are the terrain, which is the operation of some troop, but this element is a small part of a much bigger and much complex scenario. The urban system, it is always composed by subsystem. this is extremely important to understand. For example, this is very simple to understand. There is the city center, there are several sub-centers or several nodes inside the cities, and then those nodes are articulated in a very complex situation. For example, through the transportation system or through other economical or strategic factors. I don't want to discuss the single cases now. The system in general and the subsystem in detail, they are always interconnected. And every possible development have always to consider those kind of interaction between the bigger system and composed by subsystem. We also remark many times the importance of the space system, spatial forms inside the urban planning. But attention guys, this is also very important, this is also fundamental in the architecture. So we can consider cities or architecture as two different scales of the same phenomena. Now, the subsystem inside a city or the subsystem inside one architecture, it is always based on how the society, the economy, but also other drivers generate changes and especially generate dynamic in the space forms. There is a urban structures. This urban structure is composed by different subsystems. Those subsystems are generated by transportation system and space system. All those elements have to be interpreted in the direction of society and economy. According with the excellent paper of Mr. Ghaffari and others, the spatial analysis and development process and also complex and dynamic urban system evolution modeling can be employed as appropriate support tool by planners to realize and interpret the urban development and growth mechanism. It means that we know that the space analysis and the development process of urban settlement are extremely complex and especially are dynamic. There is no static in the life in general and in detail into the urban system, in the urban modeling. Every analysis that we have the intention to generate on the urban system, but in fact we have also to extend this concept in every aspect of the existence, especially the life, the biological system, we have to consider that the dynamism, it is always a fundamental element. The interpretation of urban dynamic have to be based on space relationship, dynamic in between the different parts, and important, and probably this is the most remarkable element in this section of the class, everything is related on growth mechanism. Now, growth mechanism is a very key concept because it is strictly related on cellular automata process. If you remember the cellular automata, the discussion concerning cellular automata, we know that the cellular automata is a dynamic process which concerns the growth and the development of a certain kind of cells based on certain kind of rule. Now, every city is growing, exactly like every biological system is growing. Attention, in this case, growing doesn't mean always positive growing, but also negative growing, which means decreasing of population, decreasing of individuals. Yes, because it is a dynamic system. And all these kind of elements are deeply rooted into the cellular automata process and mechanism. At this moment, we have to propose one example, again studied very well by Mr. Ghaffari and others, in order to create a very strict relationship, or better, one application of cellular automata inside the urban study. So now there are necessary some parallel, some application, we can say. The cellular automata was very theoretical, then we applied the cellular automata for some concrete case, for example, in the study of the human behavior inside limited space, and how the situation it is evolved in different cycle, different session. And now in this paper, the authors intend to create a very strong relationship, or better, one application in between a possible urban scenario and a cellular automata elaboration. So in this specific case, the lattice area coincide with the urban area. What does it mean? It is something very simple to understand. You have the geographical map of one city, but in theory of every city or territory or bioregion or something even bigger, which coincide with a country. Basically a sort of board, a physical board where the study is concentrated. In this case, we are talking about a specific model of one city, and this is the application of the cellular automata on that city. So in this case, the lattice area, the theoretical area where the cellular automata insist, coincide with a map of a real city. We know very well that cellular automata, it is based on a grid. Every grid, it is a square, one-dimension elements. But attention, here start to be very interesting. It is possible, and actually it is already done, that every single cell of the lattice area include several parameters at the same time. In this example, it is exemplified two elements, for example, residential data, commercial data, but in theory, you can insert in every single cell of the grid many parameters. So it is, yes, a zero-dimensional element, a point, but at the same time, this element could contain a lot of data. A number of the people, density of population, density of construction, or eventually the function of the area or the land value, the relationship between the single point, the single cell, and the surrounding. In short, all the elements that, in the opinion of the urban planner or in the opinion of the urban analyst, could be useful for our study. It is a sort of n-dimensional element where n it is the number of information or dimension that we intend to analyze. There are some points which could represent an area of the city which is built. For example, a residential area, for example, office, CBD, and so on. Then there are areas where there are no buildings. It is not built anything. So in that case, that area could represent, for example, the transportation system, road, railway, subway, and so on. But well, subway is a little bit different because it is underground. Anyway, even in case of subway, we can overlap the nature of this single cell which contain the subway with other function which is built above. Any cell, any single square, any single point could contain a lot of information. Include, and this is very important, the neighborhood connection, which it means the mutual relationship in between the other point. It is also very important to understand one key element. Every single point, it is not fixed forever. The data change basically minute by minute, second by second, because every cell represents the reality of the city, and the reality of the city flow, change moment by moment. For example, the condition of the traffic. In the area which is not built, which represent, for example, route or public square or pedestrian street, the area could be crowded or semi-crowded or completely free, and so on. And those elements change minutes by minutes, and it could be recorded, for example, by GIS system or by satellite or by sensors or camera, and so on. So this is the general scenario, the application of the cellular automata applied into the urban study. Then it's very important to understand that according with the logic of cellular automata, it exists some transition rules. Those transition rules generate relationship in between the different cells. But what does it mean? It simply means that the single cell represents the dynamic of the city. It defines the urban system. Now the parallel is very clear. We have a cellular automata, we have a city. What we are doing, it is to overlap those two elements, overlap the cellular automata, which is abstract, mathematical system, into the reality that we ironically call outside the windows, the life, what happened on the road. It is also very important to understand that this model, it is quite accurate, it is very interesting, because if we put the right data, and this is not difficult anymore because we have a sensor spread around all the cities, around all the world, then we can catch the real data in the world, in the real world, in the real city, in the living city, and then it can be absorbed, it can be thrown into the computer for elaboration. This is, as the sentence means, the urban cellular automata models have to be employed to study the urban system, especially as a planning support system. PSS. Now, PSS is a very common strategy nowadays for the investigation, design, but also in the generation, in the production of different possible scenarios of the city. Yes, because of the one application of this complex system, it is very interesting. In this moment, you have your city. You have the city which is the state in the moment that you are listening this lesson. After 5 minutes, after 10 minutes, after 1 hour, 1 year, 10 years, the situation obviously changes. So the cellular automata, or better, the planning support system, PSS, joined with the cellular automata, could produce possible future city. Attention, possible, statistical. It doesn't mean that it will be like that absolutely for sure, because the components are too many. So those possible different scenarios are calibrated according with the statistical analysis. So in short, it is something like we are going to produce, imagine city which respond to the classic sentence, what if? In this picture, we have one application. It doesn't matter which city is this. But on the left side of the picture, we have the city on one specific moment. We can consider T0. On the right side, according with some data which are embedded in the first case, in the first image, there is a sort of evolution. As you can see, the map of the city, it is divided into very small and thin square. Every color corresponds to one function. For example, the yellow is the beach, or for example, the pink area, it is where the tourism is concentrated. The dark green, it is the natural landscape, forest, park, and something like this. Then the red part, it is housing, and so on. In this specific case, we are discussing about one bioregion. So not a city itself, but something much more complex, which in my opinion, it is even more interesting than the urban analysis. It is the possible evolution of one region, bioregion for example, which provide for the planners possible scenario and, this is the point, avoid possible risk, avoid possible concentration. Every single square, the 0 dimension, the point, every cell contain data. For example, the density of the trees in the natural park, or the density of the tourism, or the density of the housing in the red area, and so on. Those data could be recorded moment by sensors, for example, and then, according with a very sophisticated algorithm, the computer starts to elaborate the data and understand which possible solution what if, the famous sentence we mentioned before, what if, what happen if the situation is going in this direction. And then appear the picture on the right side. The picture on the right side, it looks the same, but it is very different from the first one. For example, we can notice that the natural area, the natural landscape, it is smaller than before, it is reduced. Well, it is sad, but this is exactly what happened nowadays. The cities are going to expand, the natural resources are going to be deployed, and another very interesting element, the red area is going to grow, to increase. So this possible scenario, it shows that, attention, if the direction of the development it is according with the T0 figure on the left, then the T1 after 10 years, 15 years, it doesn't matter, it could generate that kind of scenario. Is it what we want? Is it positive? Is it dangerous, or it exists any possible risk? Well, according with the specific case, the planner could say, attention, there are some problems and we have to avoid the problems because of the possible situation, the future situation could be negative, and then they can react accordingly. This picture, in my opinion, is very important because it teaches us three possible applications, three possible strategies to use cellular automata into the urban study. I also want to remark that those kind of three cases become even more strong if we join with the artificial intelligence. Case number A, cellular automata models to generate a result that can be explained by urban theories. In this case, the cellular automata could explain the reason why the city evolved into a certain direction. We know that, generally speaking, the city evolved in terms of one amoeba, where the boundary of the city is not very well defined, but it looks like a star, more or less. So, which mathematics, which formulation could explain that kind of urban growth? Cellular automata could provide one possible theory. Case number B. We can apply the cellular automata models for the simulation of real city. And this is very interesting because the urban planning and the urban design could propose future scenario of a given city. So if the urban planner say, what is the future city that I'm going to discuss? Are we going to generate a good city or a bad city? Or, as we mentioned in the previous slide, what is the danger of a certain trend, a certain situation that now is going to evolve, and we, human beings, with our limited capacity of imagination, we cannot understand. Is it dangerous? Is it positive? Or it is maybe very positive? Or even better, in which way we can modify the existing trend in order to generate a better city for the future? So, in the case number B, the application of cellular automata models could be very useful for simulation, real city of the future. Or eventually also dynamic, which is in process on the contemporary city. In this case, we can understand if the city is going to be a good city for the future, or eventually drive the city according with our necessity. Yes, because the potential of this calculation is this. Urban planner can put some data inside which could represent one project intention, some modification of the situation, and then the simulation could show if my modification, if the modification of the human being are positive or maybe very negative. In few hours, for example, I can understand if my simulation, my guessing, my opinion could be positive or very negative for the future. The case number C, it is the use of cellular automata to develop normative planning models, to simulate different urban forms based on planning objectives. In this case, we are talking about norms, we are talking about rules, we are talking about urban planning. Urban planning, which it means a regulation where the urban planner doesn't design the city in the space, in the building and so on, but generate density, function, main road, and so on. So the planning models, the normative planning models, represent the possible different urban forms and, in my opinion, urban dynamics, it is much more wide, of the future. So we have case A, which represents the reason of the urban growth. Case B, simulation of real city today and for the future. Case C, generate possible scenario, possible dynamic, according with some norms, intention, planning that one human planner can input inside the system. In this point number C, and this is my own opinion, could be a radical innovation if we insert the artificial intelligence. Yes, because the artificial intelligence could generate parameters, could generate data, could insert data inside the cellular automata system in order to propose 10, 100, 1000, 10,000 different possible cities for the future. If we use the neural network in order to calibrate those kind of artificial intelligence process inside the cellular automata, we no need the brute force to generate 10,000 possible cities. But thanks of the calibration of the neural network, we can generate the optimal final solution. But attention, here it may start one misunderstanding. The use of artificial intelligence and the neural network will never ever generate the ultimate city, the perfect city, the best of the best forever. Because we remind once again that the city is a dynamic system. It doesn't exist the best solution ever. It exists partial solution which respond to a certain question, certain problem, certain situation year by year. This is why it is called biological system, which is called natural process, because it is evolutive. So the cellular automata models applied also in artificial intelligence, it introduces some possible realistic in this case it means not conceptual, not following the opinion of the designer, but based on mathematical models, some possible realistic development of the city. And in this case, it is mentioned a fundamental point, sustainability criteria. For example, we know very well that the sustainability nowadays, it is a must. No one can seriously consider any possible development of a city without the simulation, which will not include sustainable parameters. The city of tomorrow have to be sustainable. So, because this element, the sustainability, the ecology, it is so important, it is very interesting to simulate the possible future city with sustainable parameters and then let the machine run and generate the possible output to calibrate if the parameters that we insert at the beginning are correct or not. We are still not in front of artificial intelligence because the human being still insert parameter. What happens if we use neural network to generate the input since the beginning? The process will be much faster and much more accurate. This is why in the second point it is mentioned the idea of model calibration. Calibration, it exactly means which kind of data, which kind of parameter we insert in the real city. Then one solution could be very easy. The calibration, or better, the data, are the one which is generated by sensors spread around the city. For example, density of the population, for example, traffic, for example, time of use in the city, rush hour, and so on. The node which is critical inside the city, for example, for traffic jam and so on, they are constant in the urban study. Then in this situation, what we have is the calibration is a fundamental point. This is why the simulation of the parameters are fundamental. In this point, the concept is calibration and simulation are extremely important. In my personal opinion, these two elements have to be managed by artificial intelligence. There are some studies related on the calibration issue. For example, the multi-criteria evaluation, MCA. There are also other processes which consider the visual test, which are very good to create parameters, range of parameters. But there are other elements that the calibration can be done by a statistical testing. But in my personal opinion, the direction is neural network. I can be wrong, and if I'm wrong, I will be very happy. This slide expresses, even more clear than before, one of the possible intention, one of the possible use of cellular automata inside the urban planning and eventually also urban design. But this specific paper, it is concentrate only on urban planning. The cellular automata, we have seen in several phases of this class, it is a sort of self-generating process based on very simple rule. Now, attention, this is an element that we have to comment because no papers point out. We all know that the cellular automata, and more in specific the game of life, it is based on a very simple rule able to let the system grow. We repeat once again, cellular automata, and in detail the game of life, it is based on a series of cells and a very simple rule of interaction in between the cells. Now, this is the basis. This is an experiment of the 1970s, which it means 50 years ago. The interesting factors of the cellular automata apply in the urban planning is that the interaction rule in between the cells could be much more complicated or could be based on complex data that every single cell acquires. Take this example. In the past, cellular automata in the game of life, for example, they have only two rules of interaction in between the cell itself and the surrounding, crowding or loneliness, and only two states of the single cell, died or alive. But nowadays, thanks of the complexity of the computer and, generally speaking, thanks of the complexity of the system, there are many possible states of the single cell and many possible rules of interaction in between the cell itself and the surrounding. In addition, the surrounding itself can be much bigger than before. So somehow, from the game of life, which represents the most simple case of cellular automata, we can grow. The cellular automata process and application can become extremely complex. The logic is the same. One cell surrounded by many cells, some rule, some transition, and possibility of growth. So the core is still the same. But what it changed, it is the complexity of the data in the cell itself and the complexity of the rule of change. The example that we have seen before in the map represent exactly the idea that I'm going to express. First at all, we can say that every single cell in this picture contains a lot of data. For example, I can see that the cell red, which expresses the housing, or for example the cell pink, which represents tourism, it is a cell with real-time data. You know very well that the tourism change day by day, for example. So the cell based on tourism or natural or beach, they are reactive. The data are refresh basically day by day, but in theory even minutes by minutes. Not only, but we can imagine one single cell with thousands of data inherent inside a single cell, because every cell is not anymore a zero-dimensional point. Could be n-dimensional point, because every single cell could contain millions of data which is acquired by the local sensor. Exactly because we are talking about a very complex process and in general an holistic process, which it means in this case a process which contains the interaction in between each cell and the rest of the cell. So it is not only a relationship in between one cell and the neighborhood, which is the core of the game of life, for example. But in this case, we are in front of one single cell which react with the rest. Yes, because, for example, in this map in front of you, you can see that the tourism, the percentage of tourists, of visitors in this area could influence the whole rest of the region. This is the interesting point. Cellular automata, from the very beginning, which is the game of life, finally can become a much more sophisticated model. And here starts something extremely interesting. We know very well that the cellular automata could be used as self-generating forms, self-generating structures. And we have seen in the previous page that cellular automata could provide a useful tool, a very powerful tool, at least in 3 different fields. We already mentioned before, CA models to generate a result that can be explained by urban theories, so the expression, the a possibility about the mathematical theories about how the city grows, apply CA for simulation of real city, and CA to develop planning models. We already discussed this issue before. In this case, the cellular automata model can be very useful tool to generate optimal form for cities. This is an extremely interesting position, an extremely interesting topic, because the design of the city form, in the past, it was generated by the complexity of the mind of the designer, great artist, great urbanist, Le Corbusier, for example, or someone even better. Now, the key idea of the use of cellular automata in the self-generation of urban design and urban planning is exactly in this huge possibility to acquire data, eventually data in the real time, and then thanks of this data generate possibilities. Now, I want to repeat this point once again, very plain, because it's very important. We know that cellular automata in the game of life, it is based on a self-generating system based on simple rules. We already mentioned which one, no need to repeat. But then the question is, what happens if the single cell, the single point, it is not only die or alive, but it contains a lot of data generated by GIS, sensor, and so on. And what happens if we have not only 2 rules, loneliness and overcrowding, but we have a much more complex factors of interaction in between the cell itself and the surrounding. And point number 3, what happens if the interaction in between the cell and the surrounding, it is not limited on the neighborhood, but with the whole rest of the board, all rest of the bioregion, for example, like in the case that we have pointed out in the previous slide. Then the case becomes absolutely much more interesting. Yes, because we have an integrated system in between the cellular automata process and the geographical information system, GIS. The cellular automata elaboration, self-generation of forms, it is not only the result of basic rule, but in theory, with all the physical, social, economic, or even can include the real-time dynamic. So, in short, everything which is inside the dynamic of the urban complexity. The great possibility, the great advantage of the combination between cellular automata and GIS, it is that we can combine together real-time data. That, in my opinion, it is really a remarkable step forward, because in this case, the city can really react in the real time, and the planning can react in the real time. Now, attention. In this moment, there is one point that we need to express more clearly. We know very well as a professional that the urban planning, it is realized after many years after it was conceived. It needs years, sometimes decades or even generations to realize one planning concerning the whole city. But attention, thanks of the possibility of the information age, in fact, the city generate data, real-time data, and thanks of this automatization, cellular automata or artificial intelligence or genetic algorithms or all the technologies that we have discussed in this class, at the same time, after few minutes, but in theory also immediately, the city can react instantaneously after the data are generated. For example, there is a flood, there is a earthquake, there is a car accident, or even there is one node that it doesn't work inside the city thanks of this GIS information system and thanks of the artificial intelligence process in the design, processing, planning of the city, the problem can be solved immediately. This is a great possibility. For example, if you consider the serious problem of terrorism or security, we can analyze a crisis which happened exactly in this moment in some part of your city, for example, and automatically the city react in terms of security. This is an immense possibility that the computer can offer to the urban planning. The cellular automata, I want to remark once again, it is a generation of forms, but also dynamic inside a board. So in the case of cellular automata, coupling with the GIS, we can create a optimal forms, as the sentence said in this slide, but also optimal planning for the complexity of the whole system. So it is not anymore an issue of the single cell and the neighborhood, but every cell in connection with everything. So this is why this slide mentions very clearly that the remote sensing, which it means sensor around the city, and the GIS have to be integrated with the cellular automata. Yes, because the remote sensing, the sensors, then the acquiring of data in the GIS can be linked with the cellular automata and the transition rule inside the cellular automata. By the way, those transition rule, it is decided by the planners, for example, and they decide in which way the machine can react. We are still in front of a human intervention because the human being decide which are the transition rule. But in my personal opinion, this is only the first phase. When the artificial intelligence will be mature enough and when the neural network and the genetic algorithms will be mature in order to be used for real intelligence, self-generating process, then the city basically will react in the real time, not only in generating data, but also in the reaction, in the solution of those data. This is a very high level possibility. So the land use information, and for land use information, I really means every possible idea of land data, density, movement of the people, traffic, human being space use, economy, land value, everything. All these detailed land use information, which are recorded by sensor and then stored in the GIS, can be considered the n-dimensional element inside a single cell of the cellular automata. So those elements are the characteristics, numbers, which can generate a urban simulation. Now, this urban simulation is the situation now, but the cellular automata could generate the future city, the future possibility according with the situation which appear right now. And then we already have seen a lot of cases. The internet have several movies, frankly speaking, still not very mature, still at the very beginning, but extremely interesting in their attempt. Many cases, papers, movie, books, and so on, where cellular automata are used of form generating, in detail, model for urban planning. What it is very important is generate a sort of correct combination in between cellular automata and GIS system. In this slide, mention only the idea of generation of urban forms. which it means how the city grows formally, which could be included the typology, the morphology of the city, but also the morphology and the typology of the district, and in theory even at the city block level. But in fact, this process of generation could not only limited on forms, but in every possible dynamic and in every possible complexity of the city, of the urban dynamic. This is quite important. And another interesting point, which probably is the most useful, is the cellular automata is quick, which means that in few seconds can generate multiple possibility of planning. And then someone decide which one is better. On this point, I have two comments to do. The first one, pay attention, because the speed of development of cellular automata generates different output. For example, when you operate a cellular automata, one option that you, human being, can decide is how fast run the cycle. It is a kind of time speed. According with the time speed, the result change a lot. So this is a very critical point nowadays in the cellular automata. The second point that I want to remark is this. Who decide that the final output is good or bad? Human being again. Then the question is, because we have a so sophisticated automatization, is it correct that the human beings are the one who decide such kind of output? So we have the reality of the city. This reality of the city generate data. Those data are processed inside the cellular automata or other simulation process. Then we have a multiple possibility, multiple option, and then human being decide. Probably in the future, artificial intelligence have to decide. And here starts another problem. If everything become automatic, if everything is decided by computer calculation and simulation, where is the role of the architect? Frankly speaking, I don't worry so much about the work of architect, because as I mentioned many times in this class, the work of the architect will change in something else. For example, the architect for sure have to learn how to code. It is transformed. Something like in the past, there are a lot of people who was workers in the factories, very bad work, very heavy. Now, those people doesn't work anymore in the factory doing the dangerous work, but they are computer operator in the same factory. In the past, a lot of people take care of horses, and now they become mechanics for cars. In the past, there are a lot of chauffeurs for horses, and now we have a chauffeur for cars. So my point is, the work will be transformed. The architect will not be the same like the architect today, designer with a pencil, pen, colors, and so on, but probably we become computer operators, less artistic, but probably more performative. My main concern, it is not about our job as architect, because the work will change. My main concern is, where is the nature of the human being? So it is something much more general, much more philosophical, or even poetical, if you want. But it's a key question. Where is the nature of the human being inside all these artificial intelligence stuff? So, to conclude the discussion on this slide, an important element is that remember that cellular automata models, because are based on cells and because those cells is not zero-dimensional like before, but has many possible data, they could include economic, physical, institutional, many factors which are included in the system. System based on cells, every cell has multiple dimensions, and then there are several rules of generation forms and generation of dynamics. In this slide, it is related of one paper of Mr. Ye and Lee, which intended to study one specific issue in the use of cellular automata inside the urban planning, which touch directly the idea of density. Actually, this element, it is only one possibility how to implement the quality of the data which flow inside the cellular automata process. Yes, because we have seen, according with the previous slide, that if the cellular automata inside the game of life was very basic, with a very simple information, activated and deactivated, that's it, death or alive, in this case, the paper intends to add only one element more inside the discussion of cellular automata, which is the density. The interesting element in this paper is that they consider the cellular automata as uniform. This is the state of the art before the paper. What they want to say is, inside the cellular automata board, the platform, the grid, every cell should not have the same value, but the different value could be acquired. Different values are given. The differences concern the density. Yes, because if we want to use the cellular automata process in the urban planning, then we can insert inside the grid different value. And the different value could be, for example, the density. The density inside the city is not uniform. So how can we use the cellular automata grid for urban planning if all the grid, if all the point, all the cell of the grid has the same value? The reality, it is not the same in every single point. So the authors start to consider every single cell with a different value. For example, the density. We can use others, for example, land value, or we can use quality of the space, or many other factors. The choice of those authors concern density. Now, the great idea of this specific case, it is not the density. The density is one situation, one case, one opportunity. But the great idea of this paper is to create one more dimension, the density, inside the grids of the cellular automata network. Now, because the cellular automata is a self-generating system, in this case, the self-generating system can be based on density, or better, in order to be even more clear, the urban development, which is a typical process of the urban planning, it is based on a process of automatization, the cellular automata, where the cellular automata grid, it is based on the density gradient. Because cellular automata is a self-generating system, the urban development is influenced by the density. But this is only one case, because the density can be substituted by other factors. This is the great idea of this paper. This slide, it is more related of our job as urban planner. It is a concept that everyone touch when we discuss about the design of a city. In this specific case, the author touched the idea of compact city. We know that one of the most important discussion about the urban planning concern exactly the compact city. It's one topic, one huge area of investigation in the urban analysis. We know very well that the compact city has a certain kind of advantage. Not only advantage, there are also critical problems, but some few advantages. The paper mentioned that the compact city reduced the consumption of energy and land use. Frankly speaking, I personally don't agree on this point, because there are a lot of problems, especially in the consumption of energy for the compact city. The land use, definitely yes, but the land resources, maybe it is a critical point. So consumption of energy and land resources, maybe it is not the main advantage of the compact city. But it is definitely true that the compact city has few advantages. For example, the reduction of the energy use in transportation and the land consumption. At the same time, and this is my own consideration, the compact city have a severe problem. For example, an excessive use of the energy, pollution, eventually possible increasing of the crime. The excessive density of the city could be a serious problem for the quality of life. And this is, for example, the case of city like Hong Kong, which is a fascinating city, but there are serious problems, for example, in the green area. The green area, very few. the compact city has few advantages and many disadvantages. Anyway, this paper, it is not concentrate specifically on the quality or problems of the compact city. It simply consider the idea of density inside the cellular automata. They consider, for example, the energy used in transportation, the physical characteristic of the city, density, as I mentioned before, size, amount of open space. But one element that it is definitely true and we can support, it is that the contrary of the compact city, it is the urban sprawl, which is a problem, for example, in several American cities, such as Los Angeles, or even in Italy, for example, in the hinterland of Milan. So when you have the low density with an immense use of the territory occupied by single houses or low density architecture and urban block, then you have a severe problem in the, for example, consumption of the land use, and losses of farmland. This is a very important problem. And then I want to add also the reduction of quality of the soil, the reduction of the quality of rivers, losses of quality of natural landscape, and many other factors. So the low density city, it is good for small town, for small settlement, eventually for rural settlement, that is perfectly fine. But then when we pass the scale and we reach the megalopolis or the big cities, then this situation, it doesn't work anymore. This slide mentions very clearly a very interesting point. We know that the cellular automata, it is based on rules in between the different cells of the grid. So the question is, which one are the transition rules? So the author of the paper focus on three main factors in the urban development: urban forms, development density, environmental suitability. Urban forms, it is clear, it is the morphology, the physical form of the city. The density, and in detail the development density, so in which direction the density should develop, should grow, and the environmental suitability, which it means, is this development suitable in terms of the general environment? So in this case, the development of the cell, it is based not simply on the existing data, but in terms of probability. Read it together. The conversion of the state at the cell is determined by a development probability that it is a function of the states and other side attributes in the neighborhood, which basically means that because cellular automata, it is based on changes, on prevision of possible development of the cells, this kind of development, this kind of change, it is based on probability. This probability concern all the situation, all the state of every single cell in the neighborhood. So we launch the cellular automata start the iteration. In this paper it is also called loops, it is the same, the cycles of the cellular automata, and then the virtual city will grow. This kind of growth, it is based on the simulation of the statistical prevision of possible development of the single cell in relationship with the neighborhood. In this case, the cellular automata models will propose a sort of simulation possibility if a certain area, a cell or neighborhood cell, can be converted, can be changed in order to be developed. What does it mean? Basically, it means that we have one grid. This grid is composed by different cells. Those cells has some inherent characteristics, for example, density, and some transition rule, the three transition rules that I mentioned before: urban forms, development density, environmental suitability. Thanks to these three rules, the cellular automata evaluate statistically if the development of a single cell can be done or not. Those single cells must be empty for environmental sustainability, for example, or can be developed into a city. So this complex interaction generates one possible city. Attention, and this is the trick, this is the possibility of cellular automata. Are we talking about the best ultimate solution? No, because it is statistical. And also, do we have only one statistical prevision? No, we have many statistical previsions. This is the interesting point of cellular automata, because the system, it is not developed into every possible solution, but into a limited range of possibility generated by transition rule and state of the grid. The last part of the slide is quite complicated, so it's better to read together in order to don't have any misunderstanding. The probability for a cell to be developed is decided by the number of cells already developed in the neighborhood. There is a higher chance for a cell to be developed if it is surrounded by more developed cell. If the density factor is considered, development probability should be related to the total density of development, population for example, in the neighborhood. The probability should be explicitly proportional to the total amount of development density or population in the neighborhood. A cellular automata model should be devised to simulate urban growth and the distribution of development density. Which it means, if we won't give a comment, but it is quite clear, that because we are discussing about cellular automata and the development of the grid, the sentence simply says that how can we imagine if a single cell it is developed into a built area or have to be empty? Everything depends of the interaction in between the single cell and the surrounding. So the question is, what is the probability of that a single cell can be developed into an urban space in relationship with the surrounding? For example, if the surrounding is totally empty, the probability to be developed into an urban space is very, very low. I cannot say zero, but very low. On the contrary, if the single cell is surrounded by other cell where the attribute is city with a certain specific density, then there is a high probability that the cell will be developed into an urban space. But attention, here the factor of the density play another role, because if the density is too high, the quality of the urban space is very low. So maybe in a certain condition that kind of cell can be developed into a park, so empty area, for example. This slide concerns the logic map of the transition potential rule and confliction resolution rule, which it means how the cellular automata operate, how the transition rule generate possibility. So the logic, the structures of the operational process of this specific case of cellular automata. Please have a look. It is a very interesting but even very simple diagram which can help you to understand how the cellular automata in this case operate. This slide mentions one problem that every users, every planner find in front of the cellular automata. Yes, because the cellular automata, first at all, it is still strongly based on the preference of the user, which it means at the same time the users, the human being who operate the cellular automata, they decide which kind of transition rule have to be inserted into the system. And this is a problem because it is not clear if those transition rules are the correct one or not. Maybe there are some hidden rules which are better. But somehow this is the state of the art nowadays. The problem of the cellular automata, which is very similar to the problem of the agent, it is the calibration, the rule of transition. Who decide those rules? In addition, there is another very important issue to discuss. We know that the cellular automata could generate different result, different output, different final situation. For example, different possible city. Now, the problem is that the cellular automata, but this is the same for agent, the final output, it is not always perfect. It is not always the best possible solution. Many simulation are simply wrong. It makes no sense at all. So we still need a human being to decide which one it makes sense. In theory, this is good because we can say that, oh, well, we still need the human being to decide if the solution is good or not. But in terms of methodology, this is incorrect. Exactly because we are using a mathematical process, which is a kind of black box where the data go inside and result come outside, then the human being don't have the control of the box. But we trust the box because it is well built. This is the logic. Well, but if we won't be completely scientific in our process of construction of a system, the input data and the output data should not be based on the preference of the human. Exactly because all the system is artificial. You can call it artificial intelligence, you can call it artificial process, you can call it a mathematical elaboration. It doesn't matter. The problem is it is not human. It is mostly mathematical. So the question is, in which way we can generate one system which is perfectly trustable and only mathematical based, and not based on the preference, flavor, or opinion of one architect or one human being. Nevertheless, this method is very interesting for the planner, for the designer, because we understand that the cellular automata could generate offspring, can generate results. These results are very useful for architects and for urban designer, simply because it can generate with a very solid mathematical method forms that the human being will never imagine. And for forms, I don't mean only the general form of the city, but I mean also some structures of the city, some topological space, some typology, some morphology. In short, the cellular automata could provide a certain kind of output that the human being will never imagine. And those output, and this is the point B, it is very solid from the point of view of calculation, because we establish some transition rule and some input data, thanks of the sensors, for example, or thanks of multiple dimension element inside a single cell, which generate a complex result that, for example, the human mind can't imagine. So this kind of output, the final result of cellular automata give interesting form, but point B, those forms are based on a sort of stability of dynamical system, which basically means that the output, it is a stable result, a possible result, a statistical output, which is based on dynamic data of the city. So because the city is a dynamical system, it is clearly expressed in this sentence. The city is a dynamic process. This dynamic process generates situations. Those situations are unstable, but thanks of the cellular automata, thanks of the statistical combination of different factors together, the final output could be stable enough to generate a possible city. But attention, and here the slide, it is very clear on this point, the final result, it is not unique. It is true that a certain kind of cellular automata elaboration loop finally converge, here it is clear, converge to a certain pattern, to a certain form, to a certain final situation. But it is also true that the result could be very diverse. The interesting element is which result it is correct, and still humans have to decide. But it is also interesting the factors that you may have a very different result, but the interesting and the most remarkable point is every result may be correct. Every result, it is determined by a very precise form of calculation. So somehow, every solution is correct. Or maybe better, every solution is not that wrong. So the mistakes are not that big. So you can trust the final output. What it is very interesting is that according with a certain kind of study, the experts say that there is a very high correlation between cellular automata and the urban mechanism that commonly happen in the city every day. So the cellular automata, finally, it is a very good method to understand how the city works, and this is why we can trust. This slide is very difficult, and I only want to mention two very important points. In my opinion, what is remarkable for us, it is the first sentence and the last one. The first sentence mentions what we already stressed many times. The cellular automata, remember, it is based on probabilistic models. Probabilistic models means that there is no direct connection in between the input data and the final output. There is no direct correlation. Probabilistic, it is statistical. Another very interesting element in this slide and in this research is that the cellular automata, it is joined, it is linked with the evolutionary strategy. Because the evolutionary strategy, it is a sort of biological process. We know very well from the bionic that the nature follows a certain kind of process, which is regulated by some complex mathematical issue, complex mathematical formulation. Every biological system, it is evolutionary, and evolutionary, it means dynamic, it changes. So in this case, the cellular automata plus an evolutionary strategy can regulate the process of form finding inside the urban planning, the urban evolution. But attention, I want to add a few words, not only urban evolution, because the logic of urban evolution could be misinterpreted in terms of urban growth. That is not the point. Urban growth, it is one possibility of evolutionary strategy in the city. But it is even more interesting, in my personal opinion, the idea of real dynamic into the urban system. For example, the city can be reduced, or even more realistically, the city can be transformed. For example, there are many areas of the city which in the past were factories, for example, and they are changed into museums. This is the case of Beijing, this is the case of London, for example, but also the case of Milan in Italy. Several cities which was industrial settlement in the end of 19th century, beginning of 20s, now become completely different in their function. For example, the Tate Museum became an art museum, while in the past it was a power plant center. So in any way, the idea of cellular automata in relationship with the dynamic of the city, it is really not only form finding, but also the strategy of intervention at every possible level inside the urban settlement. A city can grow, a city can be reduced in size, could increase in density, also can be transformed in their function. Some element, some factories, some district could be reconverted into other function, and everything according with the probabilistic model inherent in the cellular automata. There are possible very interesting examples, experiment in the direction of the use of cellular automata and urban design, urban planning. This case that you can see in this slide only by words concern the use of three geometrical models and behavioral modeling. Which it means, we know very well that the city, it is an overlapping of different functions, extremely complex. No one can control very well. So this experiment intend to join together geometry and behavior. What does it mean? The geometrical model is clear. It is the geometrical form, the morphology, the topology of one city, which become computerized, simply acquiring the geometry, the form of the city in a two-dimensional system inside the computer. At the same time, the experiment intended to insert in this complex geometrical model also the behavior of the people inside the space. If in the past, for example, the previous generation of computer modeling, the city itself, but also the architecture, it was inserted into the computer only using geometry, and this it means that the AutoCAD, 3D Max, or other software include the geometry, the form, the morphology, the typology of the city or the building. In this case, the computer acquire also data in terms of how the people use the city. This second very important and very complex element, it is possible only thanks of sensors, only thanks of GIS process. So in this case, the two elements are put together. So we have the geometry of the city and the behavior of the human being inside this geometry. And in this case, it is create a sort of loop, a system of interaction in between geometry and the use of the space. This is a very interesting element, a very interesting topic, and the results are very attractive. The final result is a sort of urban behavioral modeling, which it means how the people use the city. But the interesting point, the most important point here is that this kind of behavior inside the space can be modeled, which it means there is a sort of mathematical process, mathematical system, mathematical formulation able to describe the dynamic of the human behavior inside the urban space. And the intention of this research is to create a sort of planning, a sort of decision-making process which intend to optimize or to control or to help the human behavior inside the space. This is the project in the direction of the design of future urban area, which it means if you have a city, every city has its own problem. So in which way we can solve the problem and create the city of the future? Yes, because we know very well by the analysis of UN Habitat, for example, but basically every sort of analysis converge into this future solution. The urbanization will be the future of the human being. Because of this progressive urbanization, the function of the city become much more complex, and it is clear the case of Tianjin, for example, in China, a huge system of 3 clusters, Beijing, Tianjin, Hebei, which converge into one coordinated system. How to coordinate this system without the cellular automata or much more in general artificial intelligence? The urban behavioral modeling will be the basis of every future planning for the urban areas. Until now, this kind of elaboration are generated only for a 2-dimensional system. But in fact, there is no limitation. We can consider the 3-dimensional system or even the 4-dimensional system, which it means the evolution, the possible evolution of the city in the time. But remember that the dimension in mathematics, they are only functional. We can imagine a city based on n dimension, where every dimension is one simple coordinate. Economy, for example, or density, or whenever. But even if, as an architect, we consider the city as a 3-dimensional model, or eventually 4-dimensional model if we include the time, then there is no limitation in the planning of the city for the future based on n-dimensional system. This slide expresses even more precisely the operational process of the proposal of the scholar Venegas and others. They mention that the real action in the urban planning concern the urban space in the real world, which has different variables, something like the express terrain, road networks, building shape, but also urban block, distribution of the population, density, job, transportation routes, economy, and so on. All the variables that we all know very well in terms of urban planning, urban design. All this complexity, it is basically transformed into data, into numbers. We can consider every single cell has all those elements transformed into numbers, and we can call it simply dimension. The proposal that they offer to the scientific community could touch the following example. Read together. A designer increased the height of the building in downtown area, or a designer inserted a highway into the model, or a designer modify a subset of the terrain or increase the local population. Now, those three examples are only specific cases, but in fact you can imagine every possible modification that a designer intends to do into a city. What it is very important in this experiment is that they operate three different possibilities in between many. The complexity of the city is there, outside the windows, as we said, but what it is even more important is that every action that the designer or the public administration intend to do, it is automatically calculated inside the system. How it works is very simple. In theory, in practice it's a little bit more complicated. We have the city. This city, it is overlapped with a grid, the Cellular Automata grid. Then every single cell, it is equipped with several dimensions, which is again road network, terrain, building shapes, but also data, something like population, jobs, economy, everything that you can imagine. And then the designer do some action on this model. Automatically, the system, based on cellular automata elaboration, modify the existing situation and generate not the final output, but the possible output. In this image, there is one diagram which basically means that every possible variable in this complex system, and this variable, it is considered globally or locally, it doesn't matter. It is modified, increased, decreased, or constrained in a very complex situation. So, on the contrary, that cellular automata, the classic cellular automata, which basically act only locally, or better, every cell act in the neighborhood. In this system, the situation is a little bit more complicated because we have a much more global, much more holistic process of modification. So the design, the result, it is a complex elaboration of local, global behavior. If you check the diagram, we have the users, which is, for example, the architect, and then we have two large areas of behavioral modeling and geometrical modeling. Behavioral modeling, they select some possibility: population, jobs, accessibility, land value, and so on. Geometrical modeling, it is road, block, parcel, building, and so on. Then finally, the interaction between behavioral modeling and geometrical modeling generate the 3D model of urban space. Every modification, and here is the point important in this experiment, every modification in the behavioral modeling or in the geometrical modeling generate one possible output, one possible universe. So, for example, the architect decides to increase the population, or to reduce or modify the land value, or decide to close one road, or add one highway, or modify the city blocks, and so on. Every modification of those parameters, it is simply a modification of one number, and the modification of the number will generate one output. So this experiment by Vanegas and others, it is quite practical. It is not theoretical at all. So as they mentioned, the main goal of this experiment is to provide a realistic cityscapes that are internally consistent, which it means basically that it is a software which is able to generate a possible solution, possible output of one existing city if the user, if the architect insert a certain kind of modification. Which kind of modification? Every possible modification you can imagine. For example, you can add a building, you can modify the city blocks, you can add one road, you can change the density of the city as you wish. So it is a very complex system, all based on cellular automata. As they mention in this paper, the geometrical modeling engine consists of an adaptive road network generator, parcel generator, and building generator, which it means that if the user or the architect intend to insert some modification, for example one road, automatically the city change accordingly. every possible modification that you can imagine, generate solution. Ultimate solution? No, because it is not linear, it is not automatic, but it is based always on probabilistic calculation. It is always based on cellular automata. This case include also a very difficult situation where the architect or the planner decide to insert some radical job modification. For example, they modify the function of one area from commercial to CBD, from residential to a park. So in this case, the function and consequentially also the job will be modified. The process that they propose, it is based on three main elements. Number one, a methodology for interactive urban model design that closes the loop between behavioral and geometrical model. We already discussed. In this case, we have two different key elements. One is the geometrical model of the city, the physical space, the typology, the morphology. Another one, it is the model of behavior, how the people use. So this process that they propose to the scientific community, it is a method to close together, to put together, to overlap behavior and geometrical modeling. Point number two, an interactive agent-based behavioral modeling system which simulates population and job change. Number three, a road generation algorithm that adapts the underlying population, jobs, terrain, and local transportation demand. In this case, there is several elements put together, include agent-based behavioral modeling, which is quite complicated, we already analyzed, and generate a big black box where all those elements are put together. Then the user shake the box, which it means let the machine run, and then the output propose possible solution based on statistical process. One possibility to generate this kind of complex design, it is based on a software called the City Engine. And this process, it is based on several input layers. Now, those input layers you must imagine as a sort of universe, a sort of dimension where you put data. And in fact, you can have as much layers as you want. It is a sort of multi-dimensional grid. This is the great potential of this system. Then there is a process to generate road network. I won't go into the details about the mathematics on the back of this road generator. And then after you put together the generator of road and the different layers which contain data, the method will create several possible configuration. In this case, it is a variety of road configuration, but in fact, the method may be even more general because we are in front of every possible configuration, which include parcel, density, yes, road, but also city block, and so on. So, generally talking, we are in front of one method which can generate a possible solution. In this case, it is road configuration. This slide is quite complicated because some elements are very technical, but anyway, there are some issues which is quite remarkable and it deserves a certain kind of discussion. First of all, the method that it is proposed by Vanegas, but also by other scholars in another experiment, is definitely put together, and this is quite important, cellular automata, agent-based models, and aggregate equilibrium models, which it means that every form of simulation, every form of artificial generative design, it is based on multiple techniques, in this case cellular automata, agent-based models, and aggregate equilibrium models. But we can definitely include genetic algorithms, neural network, and so on. What it is very important is that every technology is a sort of cocktails of different technology which are put together to generate an appropriate output. A second important element, it is that This kind of method has the ambition to have a sort of maximization process. Now, what is maximization? The idea of maximization, it is strictly related on process, on performance. So you have a certain kind of components, and then there is a process to optimize the result, to make the performance as better as possible. This is typical, for example, in the engineering. In the engineering, we must try to avoid the redundancy of the system. The redundancy is very important in terms of safety. For example, in the airplane, there are circuits, and generally speaking, there are at least 4 or 5 different redundant circuits, which it means the circuit is completely the same, and in case one it failed, there is another one which is totally identical. Generally speaking, it is never broken. Even the first one, it works very well. But in order to have a certain kind of safety, it is necessary to have a redundancy. Now, in this case, the maximization, it is a process to optimize the system. This is quite important because the maximization, it is always inherent every form of computational. So cellular automata or agent-based models and so on, it is always direct in the optimization or maximization of the result, it doesn't matter, of the complete system. In this case, it is also mentioned the keywords of decision theoretic agent. Yes, because we remember that the agent could be very sophisticated and the agent may become smart, if you remember the past lesson. So in this case, it is possible to consider the agent as able to take decision. Human decision? No, they are mathematical process. Attention, don't give a soul to the mathematics, which has not. But the key point here is the agent in a certain situation with a sort of sophistication, they have possibility to take theoretical decision. So you can imagine that this kind of process, it is quite complex because we have a multiple technology, multiple mathematics inside the decision making, we in the direction of optimization, and then the surprising consideration that the agents may take decision. But then probably the most important concept in this sentence is the calibration. If you check the last sentence is calibrate uncertainty in the model system. Yes, because we all know that in the human design, but also in the simulation, there are always uncertain situations. Uncertain generated by the reality. The reality, it is always uncertain. There are some random situations that may happen, and no one is able to understand what it may come next. So, very important is that the combination between different techniques, it is able to generate a sort of calibration of the uncertain possible situation in the modeling, which it means it is a sort of self-balance, self-adjustment in the direction of the optimization of the system. It's a very complex but beautiful topic. So the behavioral modeling, which is based on this kind of overlapping of different techniques, it is based on 4 different components, which are algorithms: transition, mobility, location choice, real estate developments. We read together. Number 1, transition. Add or remove population, jobs from the urban system based on interfaces with an exogenous macroeconomic model or an endogenous model. Number 2, mobility. Predicts that a subset of population job will move from their current location due to a change in living condition. Location choice predicts the places where the population job that have chosen to move will move. Real estate development imitate developers who change land use due to the economic investment or changes in the governmental regulation. So basically all this stuff, it is simply simulate what happened in the real life. Transition, mobility, location choice, real estate developments are the dynamics that are commonly running into the real city. In this case, they are all simulate using cellular automata, agent-based models, and aggregate equilibrium models. So, thanks of this complex algorithms joined together, the simulation, the software, is able to generate a sort of new configuration of the urban complexity based on those kind of dynamics. So it is a sort of new equilibrium? Yes, basically yes, but attention, what it is potentially the most interesting aspect of those process is that the simulation, it may happen in the real time. So it is not like the common plan, the common urban planning, which is generated once every 20, 30, 50 years. In this direction, using this kind of technology, urban planning can be made day by day, and this is the great potential of this new system. In the case of the geometrical modeling of the road, which is one of the elements that it is pointed out from this method, it is, for example, road length, the total length of the road inside the grid cell, average tortuosity, building volume, terrain elevation. But this slide points out a very interesting element. We must remember that a certain entity, like the road, cross different cells. So it is not anymore a simple cellular automata process like the game of life that we have seen before. It is much more complicated because the road may affect different cells. So in this case, the structure of the cellular automata, it is much more different because one element, road, but also the terrain geometry or the building or the parcel and so on, can touch different cells. So it is not one cell, one universe, zero-dimensional element. In this case, the cells could have some connection in between each other, and eventually cells which are very far in between each other can be connected by one mathematical element, which is, in our human perspective, a road. The new cellular automata process, it is something much more complicated because include not only cell by cell and neighborhood, but also mutual interaction in between cells which may be very far. This picture shows two examples which was generated by the software proposed by Vanegas and others. In this case, on the bottom of the slide, you have two different situations. It is the same city in two different moments. In the state C, you have one city on the left of the river and a small settlement on the right side of the river. And in this case, in the diagram in blue, you have the job concentration in A, which is very dense in the city center, which is very logic. In the figure B, you have the distribution of the population. Then one simulation starts, and the designer, the users, the urban planner, decide that on the right side of the river, he wants to insert a new employment area. Or I give you a very simple example, new startup, the new Silicon Valley. It doesn't matter, something like that. In one area in C, which is not full developed, the designer, the user, the urban planner, the public administration decide to insert new job opportunity, startup, for example. And then the city starts to change and change radically. So what you can find in D, in the picture D, it is a concentration of new jobs. Then the population in E will change. But because the job concentration, it is changed in D, and consequentially the population distribution, it is changed in E, consequentially in the city center of the previous city in C, you can see that the job concentration and the population concentration in F change radically. So the sequence is A, it is the job concentration, B, the population concentration. Then there is one action from the planner that say, I want to increase the job concentration, and then the situation D, it is generated on the right side of the river. Then the population will change also on the right side, but consequentially on the left side we have a decreasing the population. So the final picture in F show that the density of the population on the left side of the river decreases, and it seems to start a new city on F in the right side of the river. In this case, it is probably too simple, because it is very hard and very expensive and not very logical to create a new city where in the past there is a countryside. So in terms of sustainability, agriculture, land use is not so good. The city will be split into two parts. So it is not very logic in terms of real city, real urban planning. But the interesting point is this: the software will simulate the modification of the city, the existing city and the coming city, only because someone, the user, decided to generate a new addition of job opportunity on the right side of the river. This case is not very realistic, but what happens if, for example, the case it is more realistic? For example, the urban planner decide that we must develop the riverfront with some tourist area or entertainment and so on. Or maybe he wants simply distribute in a more homogeneous way the job opportunity only in the city posed on the left side of the river. So this case it is very good because it shows a process of generation of city based on a very articulated and sophisticated mathematical process. In these and in the following slides, it is proposed a method of generation for arterias and street. First of all, they categorize three different levels of roads: highway, arterias, and streets. With those one are the definition. In this case, we on the bottom of the slide, we have two situations: an initial situation A, and then the result B after the elaboration. So what happened? It happened that in the case A, we have a city, which seems a compact city, small compact city, and then the user draw a highway, which is in the picture B, the yellow line. And then what happened? It happened that automatically the city changed radically. Yes, because it is create some arterias and some secondary street. So there is some algorithm, there are some mathematical rules that once the users, the designer generate the main road, automatically other roads are self-generated. It is simply an algorithm, mathematical algorithm. But this is not the core of the discussion. The core of the discussion concerns the concentration of job and population. If you see the sketch A, the figure A, the blue sector, the blue area, the blue picture show that there is a very strong concentration in the city center. So the red area is a concentration of job, for example. But in the case B, once the highway it is design, the concentration of job and the concentration of population it is spread in a much larger area. So it is less dense. So, in the case B, the expansion of both streets and arterias is guided by the terrain. The spatial distribution of population and job and user-specified Steely parameters are generated by those new system of connection. It's a new road system. This kind of generation, this kind of solution, the solution B, it is created only following the new road system created by the users. Is it correct? This is not the key question in my personal opinion. In my personal opinion, this process shows how the job distribution and population distribution will change if we insert some new road. Only that. Then we may have other components, for example, land use, for example, sprawl, for example, occupation of agriculture land. Many components which can contribute to create a much better geographical area. Now, in this specific case we read together, the system determines that the new highway increases accessibility from the rural area to downtown. Then, population move to now accessible lower land value areas, and new roads and buildings are adaptively generated. In this case, the goal of the project, the goal of the design, is generate a better accessibility to the city, a better distribution of jobs. It is not considered, for example, the land use, which is one key component in every form of planning, but it doesn't matter because another study could include also this variable. Now, beside the road, there is also the important consideration of generating parcels, for example, in the case of low density or in the case of high density. Now, this is not important, it is just one experiment. The important point is how can we determine which one is the rule of parcel generator in case of low density and high density. But we can also include the building type, the geometry of the footprint, the height of the building, but in theory also the style, the envelope of a building. Include it is mentioned in this slide, the photorealistic rendering. It is only a problem of the complexity of the software. We also can include the typology of the building and not only the typology of the urban structure. We can include the function of the building, the destination, and the commercial value and the land value. Several components which are always very important in every discussion about the urban planning. I think this experiment is very clear, very useful, very good. In the future it will be even better, and this is totally fine. But I have two key questions that buzz in my mind. First, who decided this logic? Is this system intelligent? The first question, it is clear, it is basic. We find that the generation of the road, the generation of the parcel, the generation of the urban block, it is an important element in every urban design, in every urban plan. This is quite clear, and we human beings think that is the correct direction. Are we right? We know very well that the artificial intelligence sometimes is surprising. The artificial intelligence can generate output, can generate decision that the human being will never imagine. Because it is artificial intelligence, so it is something else by the human intelligence. The case of the game of Go, or the Wei Qi, or the case of the design of the circuits, or even the case of the language, which was developed independently by the human being, by machine, by artificial intelligence in a Facebook lab. In all those cases, there is the demonstration that the artificial intelligence may be, and in my opinion, it will be, something completely different by the human intelligence. For example, because they have no body, or they have a different body compared to the human being. My point is, we have seen some experiment where the land value, the road, the parcel, the concentration of job is important. But those categories are classic. This is my point. There are categories based on a classic method of development of urban planning. There is no clue, there is no proof that in the future, in the process of artificial intelligence, using cellular automata, genetic algorithm, agent-based model, or who knows which kind of crazy process, there is no proof that those categories, I repeat again, land value, job distribution, road, parcel, morphology, typology, those categories are important. Maybe other categories that we human beings consider not important, or categories that it doesn't exist in our mind, suddenly can pop up and determine a radical change. So the logic that it is used in these papers, not only the last one, but in all the previous discussion, it is not completely objective. Artificial intelligence can create something very different. The second question, is it intelligent? In my opinion, still not very intelligent. It has a process of intelligence, like cellular automata, agent, and so on, may be intelligent, but the frontier of strong artificial intelligence, it is only at the very beginning. We have seen elements which are still cellular automata, agent-based model, and statistical. It is the beginning of a future intelligence, but we are not still in front of real, strong artificial intelligence. Much more interesting, my personal opinion, is when genetic algorithms, but even more neural network will be applied on those technologies. In that case, yes, we will have real artificial intelligence and real intelligence. In this moment, we have to discuss a very important topic and, frankly speaking, one of the most fascinating. Unfortunately, we have to be a little bit short in the description of the element because some of our research is in progress, so we cannot express everything about our work. We have to touch the issue of genetic algorithm and the relationship with the artificial intelligence. First of all, what is genetic algorithm? We already have discussed in the previous class, but I just catch some key point in this section of our last class for this cycle. And the definition is genetic algorithm is an heuristic search inspired by natural selection. We already discussed what is a natural selection, we already discussed what is bionic process, and the genetic algorithm, it is simply one algorithm which it is a formulation, an equation, which is able to describe some process in nature. So I select here 5 key points which describe the genetic algorithm. Those elements come from one paper made by Lee and others called Genetic Algorithm for Building Optimization. And this title is very descriptive because in fact, genetic algorithm is extremely useful for optimization of a building, a city, a process. Now, this element is quite important. We know very well that the nature, and this is very clearly discussed inside the bionic, the nature work according with the process. So every time we study the nature, for example, in the bionic approach, we are not going to study the forms, but we study the process. Eventually, the mathematics help us to understand how this process happens, give a sort of regularity, give a sort of language to describe the natural process. Geometry is another language. So the power, the great interest about the genetic algorithm, it is exactly this. It is a formulation and then a process which is able to optimize. Optimize, it means adapt the attempt according with the final goal. So, for example, a typical question that we can ask to the genetic algorithm could be something like this. What is the best form of a building to generate a natural ventilation? Or what is the optimization of the facade in a skyscraper? And so on. We have a very clear goal, we have a very clear function, but we are not very clear about the process. Or better, it is possible to reach the final goal, but the time consuming is too high. So the key question is, in which way we can generate an automatic process, the genetic algorithm, in order to let us to save a lot of time and a lot of energy to reach the clear goal that we have in our mind. Attention, this is a key point that we need to consider because there are other attempts, for example, the cellular automata, where the goal is not really very clear. I give you a very simple example. When in the past we touched the use of agent in the understanding how the human being use the Longshan temple in Anhai, we, our team, we have no idea what is the final path, and the agent help us to find the goal, the final goal. We have certainly the key question, but attention, the question is not the final goal. The question was at that time how the people use the space in Anhai temple, and the agent generate a certain kind of path. In the cellular automata, we have no idea what is the final goal, what is the final result, what is the output, and even what is the objective of the final result of the cellular automata. The cellular automata evolve like bacteria, like virus, like the future generation of our family, but we have no clear idea what is the final solution, what is the final goal. Not only the final solution, but what is even the goal. In the genetic algorithm, the things is a little bit different, because in the genetic algorithm we have a clear understanding about what is the goal. In theory, if we have a lot of time, a lot of resources, if we are extremely intelligent, we can reach the building optimization, we can reach the most performative forms, we can understand what is the final result of our research. But it simply needs a lot of time and a lot of energy. So somehow the genetic algorithm is a little bit different compared with the artificial intelligence and with the cellular automata and with the agent-based model. Because the genetic algorithm has a very precise final goal. For example, building optimization. We can consider the genetic algorithm one of the branch which compose the universe of artificial intelligence. For example, if you ask yourself, what is the human intelligence? It is the smartness to become rich? Yes, could be. It is the intellect which can help you to compose great philosophical books or mathematical conquest or science discover, or to donate yourself to the human being to help others. Yes, everything it is a part of the human intelligence. So we can say that the artificial intelligence, it is not only one way, one technology, one direction, but artificial intelligence, it is more like a tree with several branches and several leaves. So genetic algorithm, it is one of these branch of artificial intelligence with a very specific and precise characteristics. Those 5 points in front of you, it is exactly some characters of the genetic algorithm. We'll read together. Number 1, it starts from a problem analysis to determine the solution domain and fitness function definition to evaluate the solution domain. This is clear, we already discussed. It is a problem analysis, and then finally we understand what is the solution, or at least the solution domain, the area of solution. In this sentence, it is also mentioned the idea of fitness, which I already discussed in the past class. Fitness, it means how one organism match the surrounding. In this case, it is not a natural surrounding, a physical surrounding, but it is something a little bit more simple, the mathematical environment or one problem. Point number 2. A binary or real coding is applied to represent each candidate solution. Yes, because exactly like in the biological genetics, in the biological world, there are candidates. For example, if you remember in the previous class, Homo sapiens sapiens, it is only one solution, one output of several candidates in the evolution of life. The best, we will never know. Maybe other branch of our ancestor could be better, and probably it was like this. But this is the output. Not the best, but the most fit according with a specific environment. So the nature work always using candidate, and then the best candidate according with a specific environment could win. The best candidate for a specific solution, it is not sure that it will win and prevail among the others. Point number 3. An initial population, it is randomly generated. This is very interesting because the randomness at the beginning is quite important. Why randomness? That is a sensitive point. This is a very interesting question. Because if we, human being, put a sort of initial population, initial candidate, well, the choice is subjective. If you are Chinese or Indian or American or European, German, Italian, Spanish, then your culture determines the initial population. So it is not objective, it is not neutral. It is generated according with your own personality. And maybe if your own personality is insane, like some dictator in the past, and then the initial population could be sick. So this is why it is necessary to generate the population at the initial stage. Number 4, genetic operators, including selection, crossover, and mutation, are introduced for breeding new solutions. We no need to discuss anymore about selection, crossover, and mutation because we already discussed a lot of time about these 3 fundamental points. Number 5, through the repetitive application of genetic operators and the fitness evaluation, a global optimal solution will be ultimately obtained until genetic algorithm meets the termination criteria. It means that after a certain kind of cycle, after a certain kind of loop, the genetic operators create an evolution, create different generation, and those different generations are more and more fit to the final goal. And in order, and this sentence is very clear, to generate an optimal solution. Now, on this point, we have to be more clear. There is a radical difference in between the genetic algorithm and the biological or natural selection, not only biological, but the real world, the natural selection in the physical world. Why? Because in the genetic algorithm, in the process of generation of genetic algorithm, the environment, in this case the mathematical environment, has only one goal, which is imposed by the operator, by the users, by you, by, we can say, this kind of human god. You decide, for example, that the final goal of genetic algorithm is optimization of a facade or optimization of lighting or ventilation. So the building will be generated according with that specific question. So there is only one question, very well controlled, very clear, very simple. The word, the question that you create in your mind, it's very basic. On the contrary, in the natural selection in the real world, there are 2 radical differences. First of all, that there is no only one goal, building optimization, for example, or ventilation system, but there is a huge number of components of the world, of the natural real world. But there is something even more difficult. This universe has no final goal. Then if we discuss this element in terms of theology, in terms of metaphysics, that is a completely another issue. But in terms of nature, in the small field of bionic study, the world, the natural world, has no finalization. There is no ultimate goal, and especially, and this is very important, everything is dynamic. On the contrary, the genetic algorithm has one final goal. When the loop, when the generation reach those kind of final goal, the system stops. And there is no natural selection where the system stops. Even in the collapse of a solar system, it is created a black hole, for example, or something else. So there is no real end in the nature. There is always a process which is going to develop in something else. The genetic algorithm doesn't follow this rule. And this is a radical question, radical difference in between genetic algorithm and genetics in general and natural world. In this slide, we repeat, but just to remind you, some of the key elements which concern the idea of Darwinism, the Darwin evolution of the fittest, and I mention again selection, crossover, and mutation, which we already discussed in the previous class. There are 5 different methods of optimization. We just read because it becomes a little bit technical, and our class has no intention to become technical. Point number 1, it adopts stochastic operators instead of deterministic rule to search for a solution that will allow the genetic algorithm to avoid local optimum. The idea of local optimum is very interesting simply because it concerns one problem that we already touched in the past. We know that the genetic algorithm, it is directed into find the candidate which is the most fit of a certain problem. But in this kind of mathematical process, it could happen to have a peak which is only relative, which it means is not an absolute maximum or minimum or optimum. It is a relative. So this kind of process, stochastic operators, it help the system to understand if one optimum is the global optimum, so the best solution, or only local optimum. Point number 2, it considers many points in the searching space simultaneously, not a single point, to deal with the large parameters spaces. Again, in this case, there is a search which is composed by a multiple scenario, something like a war, if you want to consider. There is several battle at the same time in different parts of the field. So the solution, the victory, it is not because one general win one partial solution, like in the game of Go, the Chinese Wei Qi. The key element in this kind of searching, it is that the solution, the final solution, it is not local, but it is global. It is the perfect example is the game of Wei Qi. In that case, the winner, it is not the absolute winner, but it is the one who takes advantage among the opponents. So in this case, there is no absolute victory, but a relative victory. And this is the point number 2, the battle, it is composed by several fighting at the same time. And the ability of the player is the one who manages several battles at the same time. So this is the meaning of many point searching space simultaneously. In the space of your research, there are several searching, which means several operators, several processing, which appear simultaneously. Number 3, it is publicly available and its code can be easily implemented, which means basically open source. Number 4, it does not require a continuous objective function. It can handle both discrete and continuous parameters. This is especially important for building applications since both types of parameters are common in building energy performance model. Number 5, it can find a multiple Pareto solution for a multi-objective optimization problem in one run. This is a very interesting logic map, and I don't want to comment because it is too complex to describe by words. I please you to stop the movie for a moment and to study this complex diagram. It's a very good diagram, and I warmly recommend you in the future to start to design this kind of logic map because it's very useful for your understanding of a certain kind of problem. This slide, it is a concentrate on the specific question that one author, Tools, Dubrow, and others mention in their specific study. Now, the key question in this case is the energy efficiency for a building envelope. So again, they use the genetic algorithm for a very specific problem, for a very limited question. And this is where the genetic algorithm work better. A clear goal, specific question, which can be reached after several loops, several generations. So, in this case, the issue they notice, because the literature is very clear on this point, that one important element in the energy efficiency of a building is the envelope. We know, everyone knows about it, the importance on the envelope. In several books, it is remarked very often the disaster of the international style in architecture, for example, which use the glass everywhere, cold climate, hot climate, anywhere glass facade, which is very stupid. It is the performance is completely wrong. It's just good looking. So the question is, how can we optimize the energy efficiency of a building with an excellent facade, the envelope? In other words, which one is the best form, the best shape, the best orientation of one building in order to have energy optimization? In this case, they studied the shape of the building, the wall and the roof construction, the foundation type, insulation level, window type, area, thermal mass, and shading. So there are several components. Attention, this research intend to find one form and the orientation of the single shape able to answer to one question, energy efficiency, but where many components are put inside. I repeat again: shell, wall, roof, foundation type, insulation level, window, area, thermal mass, and shading. The components are clear, the questions is clear. The specific direction of the research, it is direct in the minimum annual energy consumption, and for every possible climate and every possible place in the world. So it is not a research which intends to generate one solution for a specific site. It is a kind of global solution. And we will see that the result finally is very simple. Because remember that in this case, the final result, it is an average, which it means is a solution good for everywhere, which actually means it is good for nowhere. Anyway, this is only my comments. So the final goal, the final result is, we read it together, a building that consumed the absolute minimum amount of energy for its size. So somehow, thanks to the genetic algorithm, we are able to generate one form, one in architecture it is called typology, which has a very specific performance, we can say. Absolute minimum amount of energy for its size, everywhere under any form of condition. There are also other possible implementation of this study. For example, include in the calculation the given cost function. For example, you have a certain kind of money, and then this one is simply one components which you add to the genetic algorithm. This is a very important point, actually not this consideration which is clear, which is obvious, is trivial, but what it is very interesting is you can add every form, every parameters, every element in the initial genetic algorithm. For example, if you are in a country which has a certain kind of preference in terms of color or forms or symbols or family structures, it doesn't matter, you simply put those components inside the genetic algorithm. For example, I'll give you a very simple example. You live in a country where the family structures has a certain kind of complexity based on family which is called clan, so several generations together, several families which join together in a larger group, then in this case you can put this kind of structures, which is analyzed by typology, inside the genetic algorithm. And then the final result will be totally different from the result of this specific paper, because you add some components which are typical of your own country. This is a very interesting process in the genetic algorithm calculation. This slide, it is more concentrate on the process of operation of the genetic algorithm. So first of all, they say that every form of genetic algorithm, which is evolutionary concept, converge in one optimal solution. This is a radical point in genetic algorithm, simply because you have one and only one optimal solution, not multiple solutions. This is a big weakness, for example, in the genetic algorithm, because finally the optimal solution is one, which it means that all the other candidates will die. So you can imagine, for example, if in your city there is only the optimal building, only one, all the rest it is erased. So it means that your city, it is based on only one kind of building. It is wonderful, it is perfect, it is the most welcome, but it's the same food every day, forever, everywhere. The genetic algorithm has this kind of weakness, lack of variety. So the process, it is based on 3 points. Number one, rather than focusing on one potential solution at a time, the technique considers a set of solutions called population, which means candidate, different solution. These ensure a global approach to the optimization and help the genetic algorithm avoid getting stuck in a local minimum, which can be a problem with other methods. Different solution, which finally will be selected. And here is the problem of genetic algorithm, as I mentioned before. It is much better that the final solution will generate several candidates. Why? Simply because they are diverse. Simply because the diversity, the multiplicity of solution, it is much better in the Darwinism. This is a radical weakness of genetic algorithm. Number two, the genetic algorithm works with encoding of the parameters, not the parameters themselves. Parameters are traditionally encoded as a binary string, although other encoding options can be used. Number three, genetic algorithms use a probabilistic method for determining the parameter value in each successive iteration rather than deterministic rule. Again, this is a very interesting point of the genetic algorithm because a probabilistic method, it is much more open than deterministic. This is a good point, a winning point of the genetic algorithm. This slide is quite complex because it concerns the process of optimization. On the left side, we have some words which include two big steps, two big operations in terms of the design process of low energy building, the specific case described in the paper. First point is the multi-objective optimization using economical and environmental indicators to select the orientation. The second point is optimization simulation environment is presented and applied to select optimal values of a comprehensive list of parameters associated with the shape and energy features. But much more important, much more interesting, it is the right side of the slide, which illustrates the logic diagram which is able to generate the optimization. First, it starts with the initial population, mostly random, or selected by a certain kind of logic which have to be very strict. Then there is the decodification, understanding of the parameters for each individual. Generate, it is a computer program for the design of energy efficient building. Then we run the DO2 and then extract the result. And then the question, yes, no, all the individuals simulated. If no, back. If yes, then we have to link another elaboration which includes those individual simulation and joint with the issue of the cost. Then crossover, mutate, converge, and then finally optimization. So this kind of scheme, this kind of diagram is the logic of processing from the generate the initial population and the optimization. This slide is quite simple because we already mentioned many times several elements, but what it is interesting and I want simply comments is that in the genetic algorithm there are several solutions, several individuals. One population, like in the common language, it is composed by different individuals. The interesting point in the genetic algorithm is that each individuals represent one solution. And then, for each solution, an attempt it is created, which it means that there is an initial population. These initial population are selected by the same process of selection, crossover, and mutation. Then the number of the individuals in the next generation, in the next population, it is reduced and reduced and reduced again. And finally, everything converges into the ultimate final solution. This is the meaning of this page. And then in this slide, we touch the case of the analysis of the building shape. The optimization of building shape. In the analysis made by Toons-Dubrow, several candidates was selected: rectangle, H shape, trapezoid, L shape, U shape, T shape, and cross. So finally, after the iteration, after the discussion, after the calculation, the genetic algorithm find a solution which is quite obvious, frankly speaking. And the solution is, if you want a building which is optimized for every kind of climate, every kind of location, where everything is fine, is this one. Square shape, cubic shape, with the windows posed in that position, as you can see from the figures. And that's it. So finally, the solution is quite disappointing. We all know about that. But it doesn't matter, the solution. It simply verifies something quite interesting, that the human being during their process of discovering and construction of architecture, they find the optimal solution by themselves, and simply the genetic algorithm verify that assumption, verify that result. So the human being in centuries of evolution find the same output that the genetic algorithm find in few minutes. So this is why genetic algorithms, it is interesting, because we no need to spend generations to find one solution, but in few minutes the computer can find the right answer for our question. Actually, the solution is a little bit more complex, because the genetic algorithm find that the south face trapezoid, it is better in terms of annual heating energy. For cooling energy use, a north-facing trapezoid is the best. A slightly more compacted trapezoid turned out to have the lowest LCC. LCC means life cycle cost, by the way. But again, what appears clear, it is mentioned in this slide, the square is the optimum shape in every possible climate. So, if you have the question to generate a standardized building which is good for everything, then the square is the optimum envelope. What it is interesting is the genetic algorithm find what we already know after several hundred years of attempt. This is very remarkable in terms of genetic algorithm process. So the genetic algorithm method define one solution, find out one solution which is the optimum in a certain condition. So this is quite interesting for our result. This is the end of our very brief discussion about genetic algorithm application. So we described the genetic algorithm theory in the past class. In this case, we touch only one specific case, one application, a possible application of the genetic algorithm. Thousands and thousands of applications could be done. And I think this is the objective of our future class and our future research. Now, in the following part of our class, we discuss about something completely different, which is the neural network, which is one of the most fascinating topic in the artificial intelligence in general, and of course artificial intelligence applied in architecture and urban planning.